Alright, I got one for you today for Keanu. He asked me for help with some triangle stuff. Just, boring stuff, whatever. But, for you, I put on my math shirt, and I got my rockstar hat on. So that makes me a math rock star. Oh yeah, I just did that. Alright, here we go. So I'm going to first cover, this will be a series of videos, the reflexive property and vertical angles. Turns out you need to know how to do those things for geometry. So here we go. Okay, so I'm going to start off with the reflexive property and then move into vertical angles. Reflexive property is one of those things that you don't think is important. You think, well, why do I need to have this written down? Well, I'll get to that. That's going to be important in other videos that I'll show you. But basically, reflexive property just says any side that two triangles share is just equal, or any angle or whatever, whether it's a side or an angle that two or whatever more triangles share, is equal to itself. So, what do I mean by that? Take a look at this first one in red, and we'll get to the Triforce here in just a minute. So, I've got a rectangle here. You can make this rectangle by putting these two triangles together. So, if I want to use the reflexive property to say something about this, then this is what I can do. I can say, well, BC, that's this side right here, or CB, whatever, is congruent to itself. BC is congruent to BC, and how do I know this? Well, it's by the reflexive property, by the reflexive property. So I can say that this side is equal to itself and even write a tick mark through there, or whatever you want to call those. So again, this is a side right here. BC is a side that is in triangle BAC. Okay, so this side's part of this triangle. BC is also part of triangle BDC. So because they share the side by the reflexive property, I can say this is equal to itself. And even though it doesn't seem that important, that's something that you're going to need when you're doing geometry proofs. Yeah, it might be like a step, like, okay, well, how do you know this side is, congruent, or whatever situation they can give you. You're going to have to say, well, they share a side, so that's reflexive property. Okay, to the Triforce. All right. Now, there's nothing here that's really sharing a side, but if I want to use the reflexive property to make some statement about this Triforce, God, I love Zelda. This is what I can do. I've got triangle let's do this right. FEG. And that's this triangle right here. FEG. So this triangle up at the top here. And I also have another triangle that I'll just name. Here I'll go, okay, let's say triangle HEI. And then that's this big triangle right here. So I kind of just wrote these down so that you can see which two triangles I'm going to be talking about. Well, I happen to notice that they both share angle E. So I can go ahead and use an arc right here to say that the two angles are congruent. That's what this means. So by the reflexive property, I can go ahead and make this statement. And I'll just abbreviate it, RP. I hate writing out the whole thing. By the reflexive property, angle E is congruent to itself, or angle E. So this should seem pretty obvious. This is the angle that the smaller triangle here is sharing with the bigger angle here, so therefore, of course, it's equal to itself. So that's what the reflexive property is. Now let's talk about vertical angles and recognizing them and kind of their importance as it relates to geometry. Alright, vertical angles. So what in the heck is this concept? Well, basically a vertical angle says that if you can find another angle that is directly across, and I mean exactly opposite across from another angle, it's congruent. So those are the words that you can kind of think of what a vertical angle is. But I understand that just me saying it probably makes no freaking sense. So here we go. I've got this nice bow tie here. It's a bow tie that you could probably rock the town with. Especially if it had these letters on it. People would be like, huh? What? You'd be the talk of the night. Anyway, so with your bow tie, you could say, well, there's vertical angles happening here. Yeah, okay. So how do I get these vertical angles out of this shape right here? Well, if I'm looking for the vertical angles, what I'm looking for are two angles that are completely opposite of each other and therefore will be congruent. So what I'm going to do is say, well, let's start in this middle point right here. From this middle point, I notice that I have this angle right here opening up this way. So this looks like it's angle ACB. And the reason I have to use three letters to talk about that angle is because if I just say angle C, how do I know what I'm talking about? This one, this one, this one, or this one. So if I use the three letters, putting the vertex, this point in the middle, then I know exactly which one I'm talking about. ACB is the angle I'm talking about. So I'm talking about this angle right here. Well, the vertical angle to angle ACB is the one that is exactly opposite in direction from it. So this one being that it's pointed this way right here, it's pointed this way. I need the angle that is pointed this way, and that is going to be DCE. So this angle and this angle are vertical angles. Why does that matter? Because now I can write this statement that angle ACB is congruent to angle DCE. And how do I know that's true? Well, by vertical angles. And that's very important in geometry, that you state your reasoning. You're going to be asked to do that. You're going to see people write this down. And so that's the very important thing. However, that's not the only vertical angles in this problem. I could very easily have said, well, if I take these outside ones here, these are also, let me actually start from here. So if I go angle ACD, that's this big angle on the outside. Well, this one's kind of pointed this way, right? Directly opposite of this one would be angle BCE. So I would consider that also a vertical angle as well. Since I've already used one of these arcs, I'll go ahead and use two. You could use 3, 4, 40, as long as you don't use the same number of arcs that have already been used up by these. It's fine. I drew that really bad, I'm sorry, but it's supposed to be 2 here and 2 here to represent this. And we can actually write that angle ACD is congruent to angle BCE by the same exact reasoning by vertical angles. Okay, so that's one example of vertical angles. Just remember that they have to be directly pointing opposite of each other. This one's pointing, kind of opening up like this. This one's opening down. This one was opening to the right, so this one opening to the left means these two are vertical angles. These two are vertical angles. Okay, so let me show you another example that has more going on and see if we can pick out some vertical angles. Okay, I've drawn this, just a random collection of lines here. I've numbered the angles. I've got 1, 2, 3, 4, 5, 6, 12, just to change it up, kind of keep you on your toes. 7, 9, 8, 10. Secretly, I missed that one right there because I can't count. So I just was like, oops. So anyway, they're all numbered, so it doesn't matter. So I'm just looking for the vertical angles. Just tell me which ones are vertical angles. Okay, so I'm just going to look for angles that point directly opposite of each other. So you could start anywhere. Say this one right here. Here's angle 10, opening up this way. Directly opposite of that one is angle 8. So I could go ahead and say, well, angle 10 is congruent to angle 8. I could do the same thing for 9 and angle 11. Angle 9 is congruent to angle 11 because 9 opens up this way, 11 opens up that way. And we could do this for a lot of these. 1 and 12, 2 and 7, 3 and 5, 4 and 6. These are all going to be congruent by vertical angles. So this is the meaning of this vertical angles and previously reflexive property. Something that doesn't seem important, but you need to be able to use for proofs. When you're doing proofs, you might have something that looks like this or other types of diagrams, and you say, okay, do the proof. Well, in that proof, you might need to establish some things first by the reflexive property and or vertical angles. So these two things, this and the reflexive property, important things you need to know so that when you're looking at something, you can start to kind of piece a problem together. I really hope this helps. Please let me know what you think. If the Rockstar hat was too much, if the Triforce was just too much and you just have to play video games now, please let me know, because that would be really awesome. All right, I'll see you guys. Bye.